Okay guys, welcome to my channel. If you are new to this channel, you are most welcome. And on this channel I teach mathematics, science, biology, and also revise past examination papers. Today's lesson is a mathematics lesson on the topic algebra. So today's subtopic in our lesson talks about the factorization of quadratic expressions, and this is lesson number 3 on the topic. And to begin my lessons will always start with an introduction, which will also consist of a question. And today's question is, what is a quadratic expression? So before we even look at the factorization of quadratic expressions, we need to know what a quadratic expression is. So before wasting much of your time, let's look at what a quadratic expression is. So a quadratic expression is an expression or an algebraic expression with one of its variables raised to the highest power of 2. Alright, for example, this expression here, ax to the power 2 plus bx plus c, where a, b, and c are constant, is an algebraic expression because we have x as a variable and one of these as a variable raised to the highest power of 2. So we have x as a variable raised to the power of 2 or highest power of 2. So this is an algebraic expression, and some practical examples of algebraic expression or quadratic expression are ax minus 6x plus 5 and 2x to power 2 minus 4x plus 3. So let's go straight and look at what factorization of quadratic expressions is. Alright, so remember that factorization is the reverse of expansion. Right, so this you must understand from the previous lesson that I did on expansion and factorization. You must have understood that actually factorization is the reverse of expansion. So after you have expanded an algebraic expression, if you were to reverse it back, you need to do what is known as factorization. So for example, we can reverse the following expression by factorization. So we have this expression, open brackets, x minus 2, close brackets, to the power 2. So this is an algebraic expression which we can expand and later on factorize it to reverse it back to its original expression. So open brackets, x minus 2, close brackets, to the power 2 actually means that you multiply this expression by itself 2 times. Alright, so this means that you get this expression, open brackets, x minus 2, close brackets, then another one, open brackets, x minus 2, close brackets. So now, if you have such an expression, how do you expand it? So we said you multiply the first term in the first expression with the first term in the second expression. So you also multiply the same first term in the first expression with the second term in the second expression. Alright, so you say x times that expression in short. That's what it means. So let's put this expression next to x. Then next is you say negative 2, which or the next term in the first expression, which is negative 2, now multiplied with the first term in the second expression, and the same second term in the first expression, which is negative 2, must be multiplied with the second term in the second expression. So this simply means you get negative 2 multiplied with the second expression, like that. That's what that simply means. Then after you have done that, then what you do now is you multiply again the x in front of this expression in brackets with what is inside. So you distribute, use now what we call distributive law. So x by x, you write x by x, the same x must be multiplied with the other remaining term. So you say x, that is now positive x times now negative 2, you put it in the brackets. So you are done. Now you shift. Now you also say negative 2 are multiplied with x. Then you also say the same negative 2 multiplied by negative 2 in the brackets. Then after you have done that, now you multiply this. Now x times x, you get x squared. Then also you multiply positive x times negative 2, you get negative 2x. Then you multiply again this other expression, negative 2 times x, you get negative 2x. Then you multiply this expression, negative 2 times negative 2, you get positive 4. Then you copy x squared, then you add. Since these are like terms, negative 2x minus negative 2 are like terms and they are having the same sign, it means you add them and you keep the sign for the final result. So negative 2x minus negative 2x, it will give you negative 4x. Then you bring back, or you bring down the 4. So this is now our final expansion. So we have done the expansion, and what we have arrived at is a quadratic expression. All right, so this is a quadratic expression, and its factorization means reversing it back to where it came from. So that's what it means to factorize it. You reverse it to where it came from. So that's what we'll be doing in factorization. We'll be just doing the reverse of expansion. So let's look at an example of how we can do it. All right, so let's try to reverse this one here. So notice that this expression here, right, this expression here, the same x squared minus 4x plus 4. If you notice by this expression, you can notice that this x squared was only possible, or it is possible to obtain x squared only by multiplying x in the first expression with the other x in the first expression. That's what made us possible to get this x squared. And also the last expression here, 4. What made it possible for us to have this positive 4 was the multiplication we did of the second expression with the second term in the first expression with the second term in the second expression. So negative 2 times negative 2 is what got us positive 4. So if we were to do a reverse, we would just come up with that multiplication values, that when we multiply, they will give us this x, and when we multiply these two, they will give us what? The positive 4. So what we can do is just coming up with a bracket like this, open bracket x, another open bracket with x like that, because we know having this, when we multiply x times x, we will get our x squared. So now what is remaining is to know how can we get positive 4. So positive 4, there are two possibilities of getting positive 4, either by multiplying negative 2 times negative 2, or I think there are about 3 possibilities. Yeah, by multiplying negative 2 times negative 2, which can give us positive 4, or by multiplying 2 times 2, which can give us positive 4, or by multiplying 1 times 4, or by also another possibility, negative 1 times negative 4. All these possibilities can give us positive 4. So we need to put those numbers here, which when we multiply them, they must give us this. However, what we should not forget is that what also got us here is by adding this expression here with this expression here. So as we look for those terms to put here, we should bear in mind that those terms must be the ones when we multiply them, they give us this expression here, positive 4, this term here. But if we add them also, they give us the coefficient of this x here, which is negative 4. So in this case, only negative 2 times negative 2 can give us positive 4, and negative 2 plus negative 2 can give us negative 4. So here we just have to put negative 2 and negative 2. These are what got us where? Here. So even when we don't know this here, we can still look at these and also get back to where it came from by just thinking through the process I've just passed you through. Alright? So now, let us look at some examples of some quadratic expression or factorization. So we have an example here where we are told factorize the following quadratic expressions. Alright, so we have this expression number 1, number 2, and number 3. So let's see how we can answer number 1. Alright, so let's try how to answer number 1. So as usual, what we said is that if we were to answer this expression here, we had to look at this x here. How did we get at this x here? It means we had one expression having the first x and also the second expression having the first term as x, right? So the first expression having the first term as x and the second expression having the term as x. That is what got us this x squared. Now, how did we get this 6 here? So this 6 can be gotten by multiplying a number here with another number there, which can be 2 times what? Times 3. So it can be positive 2 times positive 2 and 3, or it can be negative 2 and negative what? 3. So make sure, is it true if we do positive 2 times positive 2, it will give us 6? Yes. So according to us, this agrees. If we say positive 2 times positive 3 will give us positive 6, and also we said these same ones, when we add them, they must be able to give us this value here. Is it true when we add 2 plus 5 will give us that? Yes, because as you can see, 2 times 3, this positive will give us 6, and also 2 plus 3 will give us 5. So it is true. So our real numbers we can add here are positive 2, in the other brackets positive 3. So this is how we can factor out or factorize this expression. Alright, so let's look at proving, because this expression, this factorization, if it is true, it must give us this expression back. So let's try to prove by expansion, because expansion is reverse, it must get us there. So we can get the same expression here and try to expand it. And the expansion, we said the first term in the first expression must be multiplied with the first term in the second expression. Alright, and then the same first term in the first expression must be multiplied with the second term in the second expression. Alright, so this is what it means. So we are to get x and multiply it with actually this whole expression. That's what simply that means. Also we are to get the second term in the first expression with the first term in the second expression, again the second term in the first expression with the second term in the second expression. So that simply means is you multiply 2 with the second expression there. Alright, so now the second thing to do here now is to say equals. Now you multiply x by that expression, the same x by that term. Alright, so it means x times x, it will give you x squared plus x times 3, which will give us positive 3x. Alright, then you also say positive x times x, it will give you positive 2x. The same positive x times 3, it will give you positive 6. So positive 2x plus 6, or positive 6, excuse me. Then what you will do now is to drop down the same expression here, x, and this you add, because positive 3x and positive 2x are common terms here, or are like terms, so you can add positive 3x plus 2x, which will give you 5x. Right, so when you look at this expression here, it is similar to this expression, hence our answer here was true. Alright, so let's look at now example 2. Excuse me. Alright, so now example 2 also we will do it in a similar manner. We'll say equals, so we'll make sure that we'll put brackets x in the first term, as the first term in the first expression, and here x the first term in the second expression, because we know this x here we got at this point by multiplying. This is what got us here. Then now, what for you to know what you put here is now to look at this term here, positive 5. So you look for two numbers which you multiply them, they'll give you positive 5. So this can be positive 1 times positive 5, or negative 1 times negative 5. So these are the only possibilities, positive 1 and positive 5, or negative 1 and negative 5. But what seems to work is this, because if we say negative 1 times negative 5, we'll get positive 5, and also negative 1 plus negative 5, which means simply negative 1 minus negative 5, which will give us negative 6. So you have seen multiplying this is able to give us positive 5, which is this one. Again, adding the same this here is able to give us negative 6. So this qualifies. So we can say equals, open brackets, here we can put negative 1, here negative 5. So this is our answer. We have factorized this expression as simple as that. So again, we can prove it by expansion, where we can say now the same expression, and we'll do the same process by saying we can multiply x in the first expression with x in the second expression, the same x in the first expression with the second term in the second expression, right, which will give us or which simply means x by the second expression. Alright, then also you multiply the second term in the first expression with the first term in the second expression, then you also multiply the second term in the first expression with the second term in the second expression. Alright, so this just simply means negative 1 times the second expression. Alright, so after you have done that, now you multiply x by x, there you do the distributive law, again x by 5, which will give you x squared minus 5x. Alright, again you shift there, you say negative 1 times x, which will give you negative x, again negative 1 plus times the negative 5, it will give you positive 5. So you get this as your result. Again you say equals, so you drop the whole expression, so this drops here, and negative 5x minus x will give you negative 6x. Then you drop 5 here. When you check, this expression is the same as this. So this one was arrived by adding this. Alright, so this expression and this are the same. So let us look at the last example. So now we are dealing with this last example. But when you look at this last example appears to be different because we have a coefficient there, or the constant 3 in front of the x. So the way we handle this question will be different from what we have already done with these other two. So when answering such a question now, you need to come up with a table here, and in this table you have the first thing to find, which we call the product, and also the second thing, which we call S, the sum. Right, so P stands for the product and S stands for the sum. So the product is given by multiplying 3, which is the coefficient of x of x squared, with the last constant, which is 10. So if you multiply 3 times negative 10, you get 30. So meaning our product is negative 30 there in the table. Then what will follow now here is now knowing what will be our sum. Our sum is the coefficient of negative x. So what is negative x? What is the coefficient of negative x? It's negative 1. So in front of this x here, we know that there is a negative 1, which we don't include. So the sum here is negative 1. Now, after you have done that, now you have to look for another term or thing, which we call a factor f. A factor f in that table. I've put f there as our factor. So factors are numbers that can be multiplied to give out another number. For example, the factors we are talking about are two numbers, which when you multiply them, they'll give you 30, and when you add them, they'll give you negative 1. So you look for those two numbers, which when you multiply them together, you get negative 30, and when you add them, you get negative 1. So these are no other than negative 6 and positive 5. So these are the factors. These are the two numbers which when multiplied together, they'll give you negative 30, and when added together, they'll give you negative 1. For example, if we get negative 6 times 5, we'll get negative 30. Also, if we get negative 6 plus 5, we'll get negative 1. Alright? So now, let's now do a little bit of magic. So what you have seen here is that when we multiply these, they'll give us 30, which is the product. Alright? And when we add this, they'll give us negative 1, which is the sum here. So the magic now we are doing is this, putting x in front of this and this. What do we get? So if we say negative, negative 6x plus 5x, it will give us negative x. So that's the magic I'm talking about. Just by putting x here, this one also has changed to x. Now when you look at this situation here, it means negative 6x plus 5x, it is giving us negative x, which is this one in our expression here. That means we have to substitute this x with this expression here in our solving. That's all we need now to do at this point. So we will now say equals, we'll copy the same 3x, then where there's this, we'll put this negative 6x plus 5x, then we'll bring back negative 10. Alright? So negative 10 down there. Then after that, we'll say equals, now we'll factorize now by what we call grouping terms. So when we look at these 4 terms here, we don't have a common factor, or we don't have a factor which is common to all these 4 terms. So to be able to factorize this expression, we have now to group it. So we'll factorize this because we know they have a common term, I mean factor, and also factorize this because we know they have a common factor. So a common factor for this term we have is 3x. This side is common on both. We know we have x on this one and also x here. We know we have 3 here. 3 can also go into 6. So 3 is a common factor. So when we factor out 3x as a common factor, 3x, here we will remain with x. Now, here what are we going to remain? The number of times 2 can go into x. I mean 3 can go into 6. 3 can go into 6. How many times 2? So that's what we remain with, because this x has already been factored out. So here we remain with x, here we remain with 2. So we open brackets and put x minus 2. That's what will remain here, factored out. Again, we'll shift it on this side. So we know that what is common is 5 here, because 5 can also go into 10. How many times? 2 times. So factor out here 5, we'll say plus 5. So here when we have factored out 5, we remain with x, and here since 5 can go into 10 2 times, we remain with 2. So we'll have open brackets x minus 2. Again we'll say equals. So now you will see that this one also still have a common, this expression here and this one, we still have a common factor, which is this. So we can still factor it out by writing it here. And now after we have factored it out, now what we are remaining with is this and this. So we are remaining with that 3x and positive 5. So those we can also put them in brackets. So 3x plus 5 close brackets, and that becomes our answer. Alright, so we have managed to factor out this algebraic expression, or factorize this quadratic expression. So we can as well prove it by doing the following. So we can prove it by expansion. If we can expand this and get back to this, then our answer here is correct. Alright, you don't have to prove this in an exam. It's not a procedure, but it's a way of checking if your answer is correct. So what we are going to say here is write the same and start multiplication. So same, this means that multiplied by that. Alright, so also that means that multiplied by that. Alright, so you understand. I'll be fast now. That also means that multiplied by that, which will give us that, and that, also that multiplied by that, which will give us that and that. So now say this will drop, then we'll say positive 5x minus 6x will give us minus 6, I mean minus x, then we'll drop down 10 here. So we cannot simplify this one further. So when you check this expression and this, they're the same, hence we were correct. Alright, so now we have come to the end of the lesson. If you liked it, give it a like. I mean, if you enjoyed it, give it a like. If you haven't yet subscribed, consider subscribing by clicking on the red subscribe button down there below the channel or below this video, and also turn on the notification so that you'll be updated by YouTube when I upload the next video. Alright, so I have something for you to practice at home. So you have this work here which you need to practice at home. Alright, so guys, we have come to the end of the lesson. Thank you for watching. Goodbye, see you in the next video, and please, peace.